going to talk about domain and range. And luckily, we've already seen a little bit of this before. When we're talking about domain and range, we're still looking at the inputs and the outputs. And the set of inputs that result in an output is called the domain. And the set of outputs of a function is called the range. And if you look back at the very first notes that we did, we talked about how the domain were the x values, they're the independent variables. And the range are the outputs, they're the y values, they're the dependent variables. And we're going to use two types of notation when we're talking about domain and range. The first type we talked about yesterday is the interval notation. So if we're looking at an example, say the answer is x is greater than or equal to 4, or if we're looking at the domain in that type of problem, then in interval notation, we're going to have 4, comma, infinity. Infinity always has a parentheses. And because there's an equals in this inequality, we would have a bracket. Now set builder notation, you've probably seen it before, but set builder notation uses braces. So it's this symbol. And we would still have the x is greater than or equal to 4 in there. But the set builder notation just gets a little bit more technical. We put x bar in there. And what that means is it means for all values of x such that x is greater than or equal to 4. So we're going to be working with both of those today, practicing domain and range in various situations, and mainly today we're going to deal with graphs. But just to get us started, let's look at the function that has inputs as months of the year, inputs being the domain, and outputs as the number of days in each month. In each case, the number of days is a function of the month of the year. Assume that the function is restricted to non-leap years. First part here, and I'm going to infringe on the space. In A, it's going to go over there into my B, but we have enough space to write it here. So if we want to write the set that represents this function's domain, we could write down all the months. The inputs, the months of the year. So January is a month. February is a month. March is a month. And then we get over here to November and December. I know I did not write them all. We could write them all down. I don't know that that's the best way to spend our time. But we get an idea there. That's our domain. Those are the inputs. So the outputs are how many days in each month. So when we look at representing the range, well, there's 31 days in January. There's 28 days in February. There's 31 days in March. There's only 30 in November. And there's 31 in December. And we could have listed all of them. Again, I don't think that our time is the best spent there. But I do have a little mnemonic, and somebody else showed me something different if you would like to see how to figure out how many days of the month there are. at some point in time. But let's look at a graph and stick with our domain and range here. It says the function y equals g of x is completely defined by the graph shown below. Answer the following questions based on this graph. Well, determine the minimum and the maximum x values represented on this graph. Minimum means the smallest x value. Maximum means the greatest x value. So when we look here and we're looking at our picture, notice that x is horizontal. We want the smallest x value for our points on our graph, and our graph is limited. So we can see that 1 to -3, which corresponds to that point right there, is our smallest x value. So our min is -3. Minimum is the smallest. Maximum, biggest. So when we go farthest to the right here, 1, 2, 3, 4, 5, 6, our maximum value is 6 of our x values. And it says, state the domain of this function using set builder notation. Well, let's draw our bracket there. Domain is an x, so we're going to have x bar. And all of our x's are in between -3 and 6. So x is in between -3 and 6. And then we'll put in our symbols there, which should always be those symbols. We can do the same thing for the y's. So the x's went from here to here. Our y's are going to go from the lowest y value to the highest y value when we're looking at maximums and minimums. So our minimum, what's our smallest y value? Well, 1, 2, 3, 4, 5, -5. And our biggest y value, starting at the origin here, is 1, 2, 3, 4. It's this tallest point here. And then to finish, for part D, we want to identify, in set notation, how do we represent the range? Well, this is where we want to go from smallest to biggest. Remember that range is our y value of our function, so that's why we want to call that y. And y is going to be in between -5 and 4. And it's going to be smaller than 4 and bigger than -5. Notice our symbols on that notation. So some functions, defined with graphs or equations, have domains and ranges that stretch out to infinity. Consider the following exercise in which a standard parabola is graphed. Well, there's our picture here. We've got the function x squared minus 2x minus 3 is graphed here. And then the question is, which of the following represent its domain and range written in interval notation? So essentially what we're doing on this problem, again, is we're looking for the smallest x value and the smallest and the biggest x value to determine our domain. And we're looking for the smallest y value and the biggest y value to represent our range. And so the question is here, are we going to go, if we look at this first answer, from -2 to 4? Is that going to be our domain? It kind of looks like it. but I'm not sure. And we do have it in 3 of the 4 answers, but what if the answer's 3? So maybe let's look at the range, the y values instead. So the range here says that we either go from -4, do we stop at 6? We don't stop at 6. What's happening is that our values here, there's arrows on the end of our graph, and we're going to keep going. And it says for problems like this above, always look for arrows on the graph to see if the graph is going to stretch to infinity. And because there's arrows, we do want to start down here at -4, but we've got arrows, and it's going to keep going on and on, up and out, forever and ever, which means that our answer is 3. I do want to talk about that just for a couple seconds longer, because I don't think that I did that good of a job of explaining. With respect to the range, what I like to ask is, do we have anything exactly the same? Sorry, wrong thing. Do we have a high point or a low point in the graph? That's for the range. That's for the y values. Well, we have a low point in this graph right here. That's the smallest y value, which is -4, and that was an option in all 4 of our choices over here. But then once we know that, what we see is everything after that is going to be above the value -4. And because of the arrows, it's going to continue on forever and ever. -4 is part of the graph, so we need to have a bracket. But again, the arrows indicate that we're going to stretch to infinity, as we do. So as we finish here with these last 4, again, looking at the maximum and the minimum values is helpful. When we're dealing with the domain, we're going to do both set builder notation and interval notation. If you have glanced at your notes at all, or your homework at all, what you're going to see is you're going to see some notation of SB for set builder. And so we're going to put this in set builder notation, then we're going to put it in also in interval notation, which is going to be indicated by IN. And it states that on the homework, but I can point it out now, so I'm going to. In terms of the domain, like I said, you might want to say, well, what's our minimum x value and what's our maximum x value on the circle? What's our minimum x value? Eric? -1. Isaac, what's our maximum?
5.
So when we write this in set builder notation, x bar for all values of x such that our x values are going to be in between -1 and 5. And you do want to write that in the proper order. We can do the same thing for the y's, and I don't know why I didn't write that there. Over here, for the y's, for the range. What's our smallest y value? Well, it looks like 1, 2, 3, -3. What's our biggest x value? Sorry, y value. Biggest y value is, looks like +3. So for our range, for all values of y such that y is going to be in between -3 and 3. SB, set builder. Interval notation, IN. Well, when we do this, it's -1 to 5, our two values that were given. They both have equals in them, so we're going to have a bracket. Over here for the range, -3 to 3, because they also both have equals, we're going to have a bracket. When we look at graph number 2, we want to write this in set builder notation and interval notation. We have an end point here and an end point there. No arrows, that's something to look out for. So as we look at our domain, once again, in set builder notation, we want to look for what's the smallest x value. Well, 1, 2, 3, 4, 5, -5. Our smallest x value is -5. What's our biggest x value? 1, 2, 3, 4. So it's going to be -5, or x is in between -5 and 4. But if we look at the value that corresponds with -5, notice that that's an open circle. And because it's an open circle, we're not going to have an equals there. It is a filled-in circle here. So we looked at the minimum, we looked at the maximum. We're going to do the same thing for our range for all y values such that y is going to be in between. Isaac? So what is y in between? Well, we need to find our smallest y value. And our smallest y value is going to be at -2. And our biggest y value is going to be at 1, 2, 3. So we're going to be in between -2 and 3. But we need to put our inequalities in. And notice that -2 does not have an equals. It's an open circle. So once we come up with the set builder notation, then we can put in our interval notation, which I think is a little bit simpler to write. I'm not sure if it's simpler to understand yet or not, because for some people, this is the second day that they've ever even seen it. But -5 to 4, -5 doesn't have an equals. The 4 does. So the 4 gets the bracket. When there's no equals, we use a parentheses. -2 to 3 here, same reasoning. -2 doesn't have an equals. It's going to have a parentheses. The 3 has an equals. We have a bracket. As we get close to finishing, before we actually even start on this problem, is this a function? Got a couple people shaking their heads no, which is correct. Why not? Hayden? Fails the vertical line test. But really what we're looking at here is domain and range on this one. And I can still recommend, look for the minimum x value. Look for the maximum x value. Then do the same thing for the y's. But the difference on this problem compared to the previous two is we have arrows at the end. So there's probably going to be an infinity in here somewhere. As we look at our domain for our set builder notation, what's our smallest x value? Matthew?
-4.
-4. 1, 2, 3, 4. But because we've got arrows here, we're going to continue over there past -4. We're not going to stop. We don't have an endpoint. We can't define what our maximum value is. Now on our y value, for all values of y such that, what's our lowest y value? Well, we can't figure it out. We've got arrows. Our graph is going to keep extending out. And because of that, our range in this case is all real numbers. Y can be anything. But when we go back to interval notation, and this one, remember, we're going to start at -4, but we're going to go on forever, which we can indicate with infinity. And there's an equals, so we're going to have a bracket. And lastly, how do we designate something as all reals? Well, if we look back up at the top of our paper and we look at our example there, what we see is we see negative infinity to positive infinity. Again, remember that infinity always has a parentheses. Our range here is negative infinity to infinity. It includes all values of y to the biggest possible number from the smallest possible number that we can think of. So small we can't even put a value to it. So big we can't even put a value to it. And as we finish, we've got our domain and range here. But once again, we have arrows at the ends of these graphs. And the thing is, I'm hoping that you can remember from Algebra 1 what the domain as well as the range is for a line with the slant. Anybody remember? So, first of all, I'm not a big fan of memorizing, but this is one I think you should memorize if you don't know it. The domain in our set builder notation so for all values such that x, and I don't really need to write that, I just write all reals, is all reals. But not only in a line with the slant is the domain all reals, so that means that x is allowed to be any possible value. But the range, for all values of y such that, the range is also allowed to be any y value. Anything. In terms of interval notation, we just saw it. Interval notation is negative infinity to infinity with parentheses and negative infinity to infinity with parentheses.